The new section is proving that a quadrilateral is in fact a parallelogram. Well, quadrilaterals are parallelograms. You need to know what these things are. A quadrilateral is simple. It is a four-sided figure. Quad means four. Now, 1, 2, 3, 4. That's a quadrilateral. One side, two sides, three sides, four sides. That's not a quadrilateral. Every vertex can only have what's called a degree of 2. That is, for every vertex, there should only be 2 lines coming out of them. This vertex has 3 lines. 1, 2, 3. For the record, so does that one. You can't cross again. You can start here. You can go to a second point. You can go to a different third point. You can go to a third point. You can go to a different fourth point and back to the first one. So you start at point 1. You go to any other point 2. You can go to point 3. Now, I did say you can go to any other point 4. Different. Well, you can cross. You can cross. This is not a parallelogram. A quadrilateral. This is, and this is not. You can cross. Now, this one lived up to the vertexes. There's only 2 lines coming out of every vertex, but they can't cross. Okay? Basically, think of maybe, I don't know, a rectangle out of focus. If it's out of focus, it might look like that. Okay? A very, very poorly drawn rectangle. This here is a very, very poorly drawn rectangle. Just don't cross. Okay? And don't have vertices that have more than 2 lines coming out of them. That is a 4-sided figure, better known as a quadrilateral. Now, what is a parallelogram? Parallelogram. Okay. It is a 4-sided figure. That is, it is a quadrilateral. It is a special quadrilateral. It's a 4-sided figure where both pairs of opposite sides are parallel. So, for example, this figure. This side and that side are opposite. This side and this side are opposite. This is not a parallelogram because this side and that side are not parallel. For the record, neither are these. Well, can you have one pair without the other? Sure. These 2 sides are parallel, but this one and that one are not. Those 2 are not parallel, but these are. It's not a parallelogram. Both pairs of opposite sides must be parallel. Well, these 2 are parallel. and so are those. That is a parallelogram. This is the symbol for parallel lines. You know, one pair, put one arrow. For the second set of parallel lines, put two arrows. Just like if you want to say that this angle and that angle are equal, that was the first pair that you denoted were equal. For the second pair, you put two slashes. Same with parallel lines. If you have a second pair, you put two arrows. If you have a third pair, which is impossible, but if you had a third pair, you would put three arrows. So basically, if opposite sides are parallel, these two are parallel, and so are those. Okay, that's a parallelogram. These two are parallel, and so are these two. The opposite sides are parallel. Opposite sides are parallel. And it's a four-sided figure. That's a parallelogram. Now, what are the different ways? So that was the definition of parallelogram. Opposite sides are equal. But that's just a definition. There's a lot of theorems. So that's one way to show that a quadrilateral is a parallelogram. Show that opposite sides are equal. But there are other ways of showing it. Okay? If both pair of opposite sides are parallel, or actually if both pairs of opposite angles are equal, you have a quadrilateral. If both pairs of opposite angles of a, this is how I'll write quadrilateral, quad. If both pairs of opposite angles of a quadrilateral are equal, then the quadrilateral is a parallelogram. In other words, there is no way out of it. There is absolutely no way out of this. If this angle and this angle are equal, and four-sided figure, so it's a quadrilateral, and this angle are equal, it must be that those lines are parallel, and so are these. There's no way out of it. They must be parallel. Okay, they must be parallel. There's no way out of it. Okay, and if if both pairs of opposite sides are parallel, then you are a parallelogram. So that's one way. So now I'm listing the ways of proving a quadrilateral is a parallelogram. Okay, if one pair of opposite sides are parallel and congruent, then the quadrilateral is a parallelogram. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. What is this one saying? Saying the following. If these two sides are parallel, let me actually draw it lower. If these two sides are parallel, this side and this side are parallel, and they're the same length, then it must be that the other two sides are also parallel, making this a parallelogram. So it's enough just to show that one pair of opposite sides of a quadrilateral are both parallel and congruent to one another. Okay. Now, there's a few others. There's a number of ways of showing that a four-sided figure, that is a quadrilateral, is a parallelogram. Okay, let me think for a moment. Okay. If the diagonals of a quadrilateral bisect one another, then the quadrilateral is a parallelogram. So basically, if you were to draw a quadrilateral and you draw the diagonals, this one, the one I drew, is shorter than this one. But if they bisect each other, it must be because opposite sides were parallel. It must be. There's no way around it. If the diagonals of a quadrilateral bisect one another, then the quadrilateral is a parallelogram. Okay. Similar to the first one, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If you have a four-sided figure and those two opposite sides are equal, and these two opposite sides are equal to one another, it must be that those two lines are parallel, and believe it or not, those two lines are parallel. That's yet another way of showing that a four-sided quadrilateral is in fact a parallelogram. And just for completeness, we'll say this. If both pairs, this is the definition, if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. Okay, so you have 5 different ways. Let me think if I can think of any more. But you have 5 different ways of showing that a quadrilateral is a parallelogram. If both opposite sides are parallel, or if both opposite sides are congruent, or if both pairs of opposite angles are congruent, then you have quadrilaterals. If the diagonals bisect one another, that quadrilateral is a parallelogram. if one pair of opposite sides are parallel and the same length, then you have a parallelogram. So what we're going to do is we are going to prove, we're going to have some information about a quadrilateral, and we're going to prove that, in fact, it is a parallelogram. Suppose we have, say, a figure that looks like this. All those lines are straight. A, B, C, D, E, and F. E and F. And we are told some things about this. We are given that CD is parallel to AB, and that angle EDA congruent to angle CBF. Okay, that's given. We want to prove that ABCD is a parallelogram. Okay, so we have that CD and AB are parallel. Okay. And we have that EDA, this angle, and CBF, that angle, are equal. Okay. So what we can then prove is that angle 1 and angle 2 are equal because they're supplementary to those two equal angles. Okay, so angle 1 and angle 2 are equal. Now this is very interesting. Okay, so I want to show that both pairs of angles, opposite angles, are equal. I want to show that 3 and 4 are equal. And how can I do that? I want to use the fact that we have parallel lines. Okay. So, what we have is RZ. Remember, BC, even if I extend it, BC is a transversal line. And we have these two parallel lines. I mean, I can extend it, and those two angles must be equal. They're both interior angles. So, basically just look at this. They're both interior, and they're on opposite sides of the transversal line. T for transversal. They're on the opposite sides. Okay, now let us come over here. Let us come over here. Now, again, here is a transversal. I could extend it. I can even extend this. This angle and that angle are both interior, and they are they are on opposite sides of the transversal. So that's angle 4. Okay. Now, we were told that angle 1 and angle 2 are equal. So let me put a 1 there. Okay. Now, okay, a 4-sided figure, the angles must add up to 180 degrees, no matter which 4-sided figure I draw. Say I cut it in half, okay? So I have 2 triangles, triangle 1, triangle 2. This angle plus that angle plus that angle is 180. And this angle plus this angle plus this angle also add up to 180. If you add them up, on one hand you get 360, and on the other hand you get this whole angle, and this whole angle, and this angle, and that angle. That is, you get the 4 angles. You don't really need this line anymore. Those 4 angles add up to 360. Okay? Right. Now, we know that angle 1 plus 4, angle 1 plus angle 4 add up to 180 because it's a straight angle. That is, this angle, and that happens to be angle 4, that is 180. So there are 180 degrees left over. Over here, there used to be angle 2, but they told us angle 1 and 2 were the same. So that's angle 1. Well, to get another 180, I know what to add to angle 1. And it's angle 4. But they're calling that angle 3. That's angle 4. Oh, look at this. Here is a 4-sided figure where opposite angles are equal. Okay, let us write this up. So, just to show you this. So now, when you have a 4-sided figure, you have 2 triangles, 2 180s. Well, what if you have any 5-sided figure? What if you have a 5-sided figure? How many triangles do you have? 1, 2, 3, 4, 5. If you have 5-sided figure, I claim you get 3 triangles. 1, 2, and 3. I'm not saying you how to do it that way. They don't all have to meet at one point, but doesn't matter. The angles have to add up to 3 times 180. One angle, a second angle, a third angle, and the third triangle. There's 3 angles in triangle number 2. There's 3 angles in triangle number 1. They make up exactly the angles in the 5-sided figure. They made up exactly the 4 angles in this 5 angles in the 5-sided figure. This is always true. It'll always be however many sides you have, take away 2. 5 minus 2 is 3. You'll have 3 triangles, or 3 times 180. If you have a 6-sided figure, it doesn't matter. 1, 2, 3, 4, 5, 6. 1 triangle, 2 triangles, 3, and 4. you have 4 triangles. A 6-sided figure, it will have 4 times 180 degrees. Just for the record, I could have drawn, if I'm not mistaken, all the triangles from one vertex. I can draw them from one of the vertexes. Say, this vertex. 1 triangle, 2nd triangle, 3rd triangle, there's the 4th triangle. I'm not saying the partitioning is unique, but the number of angles are. So if you have a 20-sided figure, what will the angles add up to? 20 minus 2 is 18. Be 18 times 180. Okay, that's something every geometry student should know. So let's write this up nice and cleanly. Actually, let's change the page. Remember, you could extend lines. There's no law saying you can't extend a line. So, pretty much, here is your rhombus. Sorry, here is your quadrilateral. A, B, C, D. Extend it out to E. Extend it out to F. And again, you were told that one pair of sides are in fact parallel. And the big one is that EDA is congruent to FBC, angle FBC. And that's the given. And you want to prove that ABCD is a parallelogram. Okay. So, angle 1 and angle 1. Okay, so statement and reasons. You have the given, and why that justified, it was given. You can say that those 2 angles are equal. Angle 2 is equal to angle 2. That is angle CDA. You want to see that? You can have it. CDA. Angle CDA is congruent to ABC. Angle ABC. Why is that? Supplements to supplementary angles are equal. Okay. Supplements to equal angles are equal. Angle 2 is supplement to that angle. That angle is supplement to that angle. Both of those angles, this angle and this angle, they're supplementary to equal angles. Supplements to equal angles are equal. Okay, so what I call number angles 2's, angle 2, that's correct. Okay, now I'm going to say that that's angle 1, and I am going to say that that's angle 1. Actually, this is a bit easier. I don't know what I did earlier. Basically, if I extend this out, I extend these lines. Those are alternate interior angles to parallel lines. The 2 lines were parallel. So now number 3. This angle, DAB. Angle DAB is congruent to angle BAD. Oh. EDA. EDA. And for the same exact reason, this is also angle 1. Angle FBC, this angle over here, is congruent to angle DCB. And the reason is alternate interior angles to parallel lines are congruent. Alright, so now, number 4. ABCD is a parallelogram. Why is that? If in a quadrilateral, both pairs of opposite angles are equal, then the quad is a parallelogram. Okay, nice, neat proof. 4 steps. Let's try another one. Okay, here's an interesting one. Yeah. RSOT is a quadrilateral. That's given. And MS is congruent to TP. TP. Proof, verify, conclude, MOPR. MOPR is actually is a parallelogram. You are given that RSOT is also a parallelogram. Sorry. And basically, you have this big, what seems to be parallelogram. You have a diagonal. And should be parallel and parallel. Alright, and we'll call this M, O, P, and R. And we'll call the last 2 points in order S and T. So RSOT, the inside one, the parallelogram. That is, those 2 sides are parallel, and these 2 sides are parallel. And MS and TP are in fact equal. So what we need to prove is the outer one, MOPR, is also a parallelogram. Okay. So RT and SO are parallel. That means angle 1 and angle 1 are equal because of my Z. Okay? Because of the Z. Likewise, we can probably do the same thing since RS and TO are parallel. Well, we don't have, okay. Oh, it's a parallelogram. So this is angle 2, and this is angle 2. Opposite angles are equal. Okay, let's just look at RSOT. So this big angle and this big angle are equal. Well, they're partitioned. They both have angle 1. So the rest we'll call angle 3. So those two angles are equal. Okay. So now, since this is a straight line, angles 3 and angle 4 are supplementary. The same thing over here. Angle 4s are equal to one another. Since RSOT is a parallelogram, we know that this side and this side are equal to one another. So let us talk about triangle 1 and triangle 2. Triangle 1, it has one slash, an X, and angle 4 in the middle. Look at triangle 2. It has one side with one slash, one side with X, and angle 4 in the middle. Therefore, they're congruent. Oh, this side and this side are equal. They're both opposite angle 4. By corresponding parts, they're equal. Okay, so now I have one pair of opposite sides equal. I just need to show that the other one is also equal. Well, let's look at angle T. Let's look at T. If you go all the way around, it's 360. But angle T is broken up to angle 1, and angle 3, and angle 4. Well, there's only one number to add to it to get to our 360. But now, if you look at point S on the other side, we have a similar thing. We have angle 4 and angle 3 and angle 1. The rest must be it must be angle 5. It's what you add to 1 plus 3 plus 4. Angle 1 plus angle 2, plus angle 3 plus angle 4 plus X must equal 360. And at point T, you also have angle 1 plus angle 3 plus angle 4 plus angle 5 is equal to 360. If you subtract, we'll call it angle Y. You have that angle X minus angle Y is equal to 0. So angle X and Y are equal to one another. Okay, so I can now slip in angle 5. Okay. And that's where I think I have it. So first, these problems I think you have to think through and then write up. Angle 5. Okay, since SO and RT are, since RSOT is a parallelogram, I know that those two sides are equal in length. But that's enough for me. Look at triangle number 3. It has a V, it has an X, and in the middle, it has what I've been calling angle 5. In triangle 4 down here, it has a side with an X, it has a side with a V, and angle 5 right in the middle. That means opposite angle 5s, V with a cross in it, they must be equal. Well, that's enough for me. I show that opposite sides, both pairs of opposite sides are equal. So yeah, it really is. Now, let's go through this again, write it up nice and neatly. There it is. M-O-P-R. Show that that's a parallelogram. And we have R, S, O, and T. That's a parallelogram. Okay. RT and SO, parallel. TO, RS, parallel. The first thing I want to say is that those are equal in length. Those are equal in length. Statement, reasons. The first one, we know, the givens. Number 2, RT is congruent to SO. And RS is congruent to TO. Properties of parallelogram. That is, opposite sides are equal. Okay. Angle 1, equal, opposite angles. Those two angles, equal. Those two angles are equal. Okay. Angle 1 is SRT. Angle SRT is congruent to SOT. SOT. And the reason is properties of parallelogram. I don't think I want to say this yet. Now I want to talk about alternate interior angles. What happened? I didn't have the marker down. I want to talk about alternate interior, maybe alternate exterior. Okay. Angle 2 and angle 2 are equal because of this line and this line are parallel, and they are, and here's my transversal. This is my transversal. You want to see those lines longer? Fine. Angle where those two angles numbered 2, they're interior angles and they're on opposite sides of the transversal. Okay, statement number 4. Angle 2 is RTS or RTM. Angle RTS is congruent to TSO. Angle TSO. Alternate interior angles of parallel lines are congruent. Okay. So I really want to get those outer sides equal to one another. I can get those two inner triangles congruent. I can get them congruent. Okay? Angles 3 and angles 3 are equal. Supplement, because they're both supplement to angle 2. So number 5 is angle MSO. MSO is congruent to angle RTP. RTP. Supplements to equal angles are in fact equal. All right. Number 4 and number 4, they're equal. And I can say that this triangle here and this triangle here, they both have two angles that are the same. They both have angle 1 and they both have angle 2. So the third angle has to be equal. Or I could invoke that RS and TO are parallel and say that angle 4 is alternate interior angles. So, I could have stuck it in the next line. I'm going to stick in with number 4. Angle RST is congruent to angle STO. Alright, so now I have that. So now I can say that this angle, remember, this is a straight line. The angle 5 is supplement to angle 4. And I don't know where to put that point S, but this is also angle 5. So number 6 is angle 5s are equal. MSR. Angle MSR is congruent to PTO. Angle PTO. And the reason is, it's funny. I could have hooked this up with number 5. Supplement to equal angles are themselves equal. Okay. Now all I know is RSOT. Wonder how I got this before. We were given that MS and TP are equal. Well, that's enough for me, because if we look at what I'm calling triangle 1, it has one slash, one side with one slash, one side with two slashes, and angle 3 in the middle. If you look at triangle number 2 over here, it has one side with one slash, one side with two slashes, and angle 3 in the middle. So I'm going to have to erase most of this, but I can now say that those two triangles are in fact congruent. These two triangles are in fact, these two triangles are in fact congruent. Okay, exactly what I said before. So I think I was up to number 7. If I'm wrong, I'm sorry. Okay, so now I can say triangle 1, which is RPT, triangle RPT, and triangle MOS, triangle MOS are congruent. And the reason is our side, angle, side. And now I can say that RP and MO are congruent, because they're both opposite angle 3. So, number 8. MO is congruent to RP. Corresponding parts of congruent triangles are in fact congruent. Okay, so now I have one pair of opposite sides equal. But now when I look at triangles 3 and triangle 4, you know what? Two sides, two sides have two slashes with an angle 5 in the middle. But same thing with triangle number 4. Angle 5 is in the middle. SAS, side, angle, side. Those two triangles are congruent. So number 9, triangle MSR is actually congruent to triangle 3, which is PSO. Side, angle, side. And now this is where we wind down. Now I can say that MR and PO are equal. MR is congruent to PO. It's a very, very long, tedious proof. Corresponding parts of congruent triangles are congruent. MS should be MR. Sorry, MR. Alright, so now I'm done. Took long enough. MOPR is a parallelogram. MOPR is a parallelogram. Reason? If a quadrilateral has both pairs of opposite sides equal, then the quadrilateral is a parallelogram. Okay, so these proofs are long and tedious, but you can do them. Just keep hacking at it. I was able to do it. Okay, that completes this section.